Hello and welcome to Calculus from Home. This is Mrs. Shiwi and we are going to do lesson 8-1 on video, I guess, this year. So things are still unknown as far as what's going to happen for the rest of the school year, but we should get some information in the next couple of days. For now, I'm going to try to post lessons for Chapter 8 so you can watch the videos and do the assignments at home, and then we will work on practicing for the AP exam after that. So here we go. Lesson 8-1 has some different sections, so I'm going to break this video into 4 different parts. The first part, the good news, is it's lesson on linear motion revisited. So the good news is we've actually done this before, but we're going to talk about it more in terms of the integral and finding it to using the integral to calculate net change and total accumulation. So we're looking at how far the particle traveled and things like that. So we'll just start with one example. There's more examples in the book if you need them, and you can always ask me questions and we can do some stuff on Google Classroom as needed. So for the linear motion problem today, we've got a velocity of 10 minus 2t is the velocity in meters per second of a particle moving along the x-axis for time 0 to 9 seconds. We're going to use analytic methods, which means we're going to use calculus, to determine when the particle is moving to the right, to the left, and stopped. So, to the right, my writing on my laptop is not excellent, so bear with me. Okay, so how do we know when a particle is moving to the left, to the right, or stopped? Well, this is velocity, and velocity is how it's moving, so it's stopped when v of t is 0. And it's moving to the right when the velocity is positive, and it's moving to the left when the velocity is negative. So we just need to find out when that happens. We have the velocity function, so we just set that equal to 0 to find out when it's stopped. Subtract 10 and divide, and we get at t equals 5. So we know it's stopped at t equals 5. So it must have been moving before and after that. So let's just pick a number between 0 and 5, like 4. If you plug a 4 into our velocity function, you get 10 minus 8, which is positive. So if I am less than 5, I'm positive. So the interval where it's moving to the right is from 0 to 5. It is including the 0 because this up here has the less than or equal to. It is not including the 5 because at 5 it is stopped. Then after that, if we pick any number bigger than 5 and plug it in here, we're going to get a negative value. So it's moving to the left from 5 to 9 because that's the time my particle is moving. That is part A. Alright, so moving on to part B, this is where we get into the actual total displacement kind of problem. So for part B, to find the particle's displacement for a given time interval, we're going to need to calculate the integral. The integral is total displacement. So from 0 to 9, for my velocity function, dt, how far did it go? Well, my velocity function is 10 minus 2t dt. So I need to find and actually do the computation of this now. So what is the antiderivative of 10? And what is the antiderivative of minus 2t? And I'm going to evaluate that from 0 to 9. Put parentheses around this to make it have better notation. Now I can do that computation. If I plug in a 9 in here, I'm going to get 90 minus 81. And if I plug a 0 in here, I'm going to get 0 minus 0, which is 0. So 90 minus 81 is 9, minus 0 is 9. This means that the particle moved 9 meters over that time period. And which direction did it move? Well, because it came out to a positive number, it moved 9 meters to the right in that time period. They're going to want to know that. We can answer part C pretty quickly here, so we'll just do that on the same part. Here was part B, and here's part C. Part C says if the starting position at time 0 was 3, what is its final position? Well, I know if it started at 3 and we went 9 to the right, that I could just get to add 9 to that. So its new final position is at 12 meters. That's all you have to do for part C. Now, part D, total distance traveled. Well, this thing was going to the left and to the right, and it ended up only 9 meters from where it started. So how far did it go to the left, how far did it go to the right, and I need to add those two absolute values together. So we need to separate this integral. Instead of going all the way from 0 to 9, we need to figure out how much it was going to the left and how much it was going to the right. So we did that with part A. We figured out from 0 to 5 it was going to the right. 10 minus 2t dt. And we could add the absolute value of the other one, or we could just subtract from 5 to 9. Lots of ways to do this. Or you could add from 9 to 5 and switch the order of the integral here. But I like to subtract the left direction. So to the right, we're going to take the number to the right, and then we're going to subtract, because this is going to come out how far it went to the left. And that will give me total distance traveled. So we're going to use our antiderivative again, which we know is 10t minus t squared from 0 to 5. And we're going to do 10t minus t squared from 5 to 9. And use your notation, use your parentheses, they need to be in there. And then evaluate. So when we plug in a 5, we're going to get 50 minus 25 minus 0. And then over here we're going to get 90 minus 81 minus 50 minus 25. And I probably should have like another parenthesis around that. So 50 minus 25 is 25. 90 minus 81 is 9 minus 25. 9 minus 25 is negative 16. So we have 25 minus negative 16, 20, 30, 41 meters. So the total distance traveled, they went 25 meters to the right and 16 meters to the left. So total distance traveled is 41 meters. That concludes the first part of chapter 8.1. We will have some more sections posted shortly.